Hello pchemmers. I wanted to record this small video as an encouragement for tomorrow's exam. One thing I want to convey is that I'm interested in your success. Now, my definition of success is for you to be confident and competent. So that's the key to success. It's not just knowing some facts, it's being competent and confident to know how you can apply the knowledge that you have to the problem at hand. Now, I know from the past experience in exams and students, especially preparing for the first exam in physical chemistry, frustration comes from blindly aiming at a target and then finding out that you missed the mark. Therefore, I'm explicitly telling you where to aim. So I have the exam finished now, and I'm going to tell you exactly what's on the exam. Now, I'm not going to tell you the specific examples that I'm going to use, but you're going to know exactly where to aim and how much to focus on each of the different pieces that are on this exam. Page 1, you're given a molecule and you need to know about hybridization of orbitals. You need to know the angles that are associated with those orbitals. You also need to know what a dihedral angle is and how to understand the angle associated with a dihedral angle or with an angle between three atoms. You're going to need to know how to draw the coordinate system on that molecule, and you're going to need to know about the symmetry elements that that molecule has or does not have. And then finally, this might have been something that threw you for a curve, but I did mention it in lecture, and that is you need to know about the total degrees of freedom, the number of rotational degrees of freedom, translational, vibrational, those kinds of computations for a given molecule. Then I have a simple calculation related to the particle in a box energies, and as far as the history, you need to know the names associated with the various failures of classical physics. There's one question on that, but still, you don't want to throw away any particular points. Then I give you a couple of examples of finding a point group for some classic molecules. Then there's some questions about the Hamiltonian operator and energies of wave functions. Also understanding some basics of analytical calculus as it relates to the second derivative that's in the Hamiltonian. And finally, the concept of orthonormality, understanding what that means and being able to simply evaluate an integral if you're given the different quantum states that you're dealing with. You don't have to do the integral, but you have to understand the concept of orthonormality. Then there's a direct product question where you can take the direct product table and I just test to see if you know how to use the direct product table. Then there's a molecular orbital given, and you need to recognize the symmetry of that molecular orbital. You're given the point group, so you know what point group you're in. But you also need to know how to find the particular symmetry of that orbital in that character table associated with that point group. There's also a direct product set up to know if if a transition is allowed or forbidden. And so you need to know how to do the direct products of things that have more than one dimension. So like we did in class, we had E times E times E. You need to understand how to do that kind of direct product. That's essentially it for the multiple choice parts. For the open-ended questions, you know how much I emphasize the transition equation, and so you're certainly going to need to know how to come up with the transition equation if I give you the particular transition series that I want you to compute. We did in class the n plus 1, n to n plus 1, n to n plus 3 examples in class, and so that's the kind of examples that I want you to be familiar with, and then you should be able to come up with the one I give you in the exam. Also, the vocabulary associated with transitions. If you're given a stick spectrum, you should be able to identify the quantum transitions and assign those, like n equals 1 to 2 or 3 to 4 or 1 to 5 and so on, and know what the names of those transitions are, whether they be hot bands or overtones or fundamentals. Also to know what happens as we cool systems down, what transitions go away and what transitions are retained. And then the last problem is related to the analytical calculus examples that you did. There's no way for me to, on a 50-minute exam, ask you to compute a transition dipole moment integral, but in those transition dipole moment integrals, you reached a point where the integral was finished and you were evaluating the statement at the end. And you had to determine whether it was zero or non-zero. And so I'm really interested in seeing your thinking related to the trigonometric equations, these wave equations, and if you can articulate why a certain result is zero or non-zero. So that's that specific step related to the ending of all of those computations, whether it be the orthonormality relationships or the transition dipole moment integrals. I just want to make sure that you understand how to evaluate the last step in any one of those analytical calculus computations. So that's it for the exam. Notice there's only about 3 or 4 point groups. There's a few, like 1 or 2 questions on hybridization and so on. So you shouldn't focus on any one area thinking that's going to be the majority of the exam. And if you're thinking, well, I can skip this topic or can skip that concept, realize that you're throwing away 4 points with every problem that you decide to not study. And so that's a very bad practice. I think you should make an effort to aim at the whole exam, and that you should strive for every point. Bearcats aim high, and so I want you to make me proud by aiming for the whole thing and finishing strong. All right? I'll see you tomorrow morning.